Hello everyone, my name is Tyler Mackey, and today I'll be teaching you all about Kamiak Butte. This video is made for the School of the Environment at Washington State University. We're going to focus on four major things in this video: how the butte was formed, its effects on the surrounding area, the microclimate of the area, and the ecosystem of each aspect. I'm going to kick things off by talking about the formation of the butte. We're starting way back to around 250 million years ago, when all the continents were mashed up into one supercontinent, called Pangaea. Pangaea began breaking up and moving due to seafloor spreading and subduction. Seafloor spreading occurs at mid-ocean ridges, or breaks between the ocean, which allows hot magma from the mantle to rise out and cool on the edges of the cracks, creating new rock and slowly pushing the crustal plates apart. While seafloor spreading creates land and pushes it around, subduction reverts it back to magma and pulls land around. This occurs near coastlines where very dense oceanic crust meets the less dense continental crust. This forces the denser oceanic crust down into the mantle, where it melts and becomes parts of the magma in the convection currents. This cyclic motion can drag continents along with and is part of seafloor spreading and subduction. This process changed Pangaea into the shape of the continents we know and love today. While all of this was happening, Kamiak and the entire Palouse were underwater. This gave Kamiak Butte a base layer of sedimentary rock that slowly over time became metamorphic quartzite. Once the Palouse was in the area it is today, very fast-flowing, low-viscosity lava began to spill out of cracks in the crust. These were called flood basalts, and they began around 15 million years ago. Lava spilled out and spread across most of the Palouse. This happened dozens of times and covered it in around 2 kilometers of basalt rock. Kamiak had managed to avoid this due to it being a natural quartzite mountain, so in a sea of basalt it sticks out as an island of quartzite. Once the flood basalts stopped occurring, the other type of floods began to take place. The most recent ice age had taken effect around 2.6 million years ago and caused the majority of the northern hemisphere to be covered by glaciers. Once this ice age started to end, the ice began melting and caused an extremely large lake to form in northern Idaho called Lake Missoula. A natural dam made of ice was the only thing stopping it from flooding over the Palouse, so once the ice dam got weak enough, the water did just that. This flood charged through Washington with speeds around 80 miles an hour and with 13 times more water than the Amazon River. The water picked up anything in its way: boulders, trees, and the unfortunate animals caught in its path. The water hit a wall at Wallula Gap. This area, so it forced the water to slow down and deposit all the debris that got carried along with it. Once the whole area was settled, the plants and animals were decomposed in the soil that got deposited along with them. This created a very nutrient-rich soil called loess that was blown across the Palouse by high winds. Kamiak Butte was now covered in this loess instead of just being bare quartzite. Now that we've talked about the geological foundations of Kamiak, we can talk about its impacts on the local weather and ecosystems. At its peak, Kamiak Butte stands around 3,600 feet tall. This is about 1,000 feet taller than the land surrounding the butte. The difference in height plays a large role in the weather for the area. An air mass called the marine polar air mass collides with Kamiak Butte's north aspect. An air mass is a large amount of air with relatively the same temperature and moisture content. This one was formed over the Pacific Ocean, so it's very moist and cold. When it collides with the north aspect of the butte, it pushes all the moisture higher into the air. This sudden change in height forced the air to release its moisture into the area. After the butte, the land is drier than before. This effect is called a rain shadow, and is when an area receives a greatly reduced amount of rain due to a mountain or hill in the air mass's path. This creates a drastic change in microclimate between aspects. Biomes are classified by the main type of vegetation that grows. This is done because plants are unable to move between environments freely, so they must deal with their environmental pressures by evolving. This gives plants the adaptations they need to survive in an area the best. The Palouse and Kamiak are part of the western interior shrublands biome. This is where a major form of vegetation are shrubs and grasses. The microclimate of the north aspect of Kamiak allows it to be a different biome, which is the woodlands biome. The difference between aspects comes back to the geological composition. Since Kamiak is made up of quartzite and loess, the area is not very good at retaining the water that plants need. The rocks and soil have large pores that water is able to flow through easily. This causes the water to flow deep into the ground along with any nutrients they pick up along the way. The north aspect is different in the fact that it has a small layer on the top of loess called humus. This top layer of soil is where dead plants and animals go to decompose. It makes a very dense and nutrient-rich layer of soil. It's harder for water to flow through, so it gives plants enough time to absorb the water and nutrients they need to grow. The north aspect has many hardwood trees that take advantage of the easily accessible water, like Douglas fir, ponderosa pine, and western larch. Underneath this canopy, blue elderberry and snowberry bushes grow with many grasses to make up the understory of the vegetation. Small birds and mammals will make their homes in the trees and eat the berries of the shrubs. Ungulates like deer and moose eat the foliage of the understory, making the ecosystem reliant on these shrubs. The south aspect has the same vegetation, just less numerous. There are only 35 trees per acre compared to the north's 172. The lack of humus is the cause for this, and that barely have grasses covering it. Rocks and bare soil are visible all the time, while the north aspect has hardly any exposed soil. There is very little crown coverage, or the amount of sky covered by the trees, so the understory receives lots of direct sunlight. Combining that with the drier environment makes it harder for plants to grow. All animals living on the butte can be found on both aspects. However, deer and wild turkey can be found more commonly on the south aspect. Finally, I'm going to talk about mass spectrometry of Kamiak Butte. This is used to show the difference of the soil and how plants make use of each element. Mass spectrometry is a tool that measures the percentage sample. In this case, it will be the amount of carbon in trees on Kamiak Butte. To obtain the sample, we're going to need a couple materials. We need a straw to store the samples in, a measuring tape, an increment borer, then a pen and tape to label the samples. When you find the tree you want to take a sample of, you must first find the diameter of the tree using the measuring tape. The borer is then placed on the tree and turned counterclockwise to drill into the core. Once you reach halfway through, the core sample is ready to extract. Insert the extractor into the middle of the borer and turn it counterclockwise again to loosen the core. Remove the extractor and place the sample in the straw. Once you're done taking any more samples, you must dry them out. This is done by placing them in an oven at 60 degrees Celsius for 48 to 72 hours. If there was water in the sample, it would skew the data when combusted inside the spectrometer. Once fully dried, then the sample is ground into a powder and is ready to go. 22 samples were taken from Kamiak and processed in the spectrometer. The data given is now shown on the right. What this means is that the north aspect has more carbon contained in plants than the south aspect. This is due to the north having more biomass. The more trees an area has, the more sequestration that will occur. The moister conditions and higher nutrient availability provided by the humus allows the plants to grow taller, which in turn allows more carbon to be stored in them. They then provide more nitrogen to the soil when they decompose, which creates a snowball effect in soil richness. Finally, I will discuss the effects of carbon and nitrogen for plants. Nitrogen is used to make chloroplasts, which in turn uses carbon dioxide to do photosynthesis. The nitrogen is acquired from the humus, the part of the soil that is made up of decomposed plant matter. Plants absorb it through the roots with the water that obtained the nitrogen when it flowed through the layer of humus. Carbon is used to create sugars in the plants as food. Since nitrogen is used to create chloroplasts for photosynthesis, the less nitrogen that's in the system, the less carbon a plant can photosynthesize. They extract carbon from the air in the form of carbon dioxide. The carbon is then stored all across the plant's tissues, such as the leaves, roots, or stems. And with that, we covered all the topics presented at the start of the video: the formation of the butte, the climate and its effects on the area, as well as the ecosystem. Thank you for taking the time to listen to this video, and